Welcome to section 11.1, Concepts of Measurement. We're going to be covering a lot of topics here in 11.1, so make sure to read through the topics, the objectives, the standards we'll be covering, and the vocabulary and concepts. So measurement is about determining the size of things. In this section, we're going to focus on the ideas underlying measurement. So why do we need to specify measurement attributes, the order and additive structure of measures, and then the actual units of measurement. And then we'll see how these ideas are essential to understanding the process of measurement. And then we'll examine the systems of measurement. So sometimes when we're teaching in the classroom, we may just jump to, okay, these are the systems of measurement, but it's really important that we have a clear understanding. So measurement allows us to describe or determine the size of objects and then also to compare them. So we want to determine the size and compare. But can we always say unambiguously that one object is larger than another? In some situations, there is ambiguity about relative size because it's possible to measure an object with respect to several different kinds of attributes. In this section, we're going to have you explore problems. These are so important for you to uncover the material before you learn about the explanations and the facts. Remember that in explorations, I don't always give you the exact answer on the next slide because there isn't always an exact answer. The point is less about getting the right answer and more about playing with the material. So please don't skip these. Please pause the video when we get to them, get the materials it requires, and spend some time and have some fun. So here's your first You Explore for this section. Press pause, read it over, answer all the questions, and press play when you're ready to move forward. So in that exploration, if we were to compare by volume, General Sherman would be considered the largest. If we were to compare by height, the Mendocino tree would be the largest. If we were to compare by the land they cover, the banyan tree in Calcutta is probably the largest. There is no single measure attribute that we are required to use. They didn't say what to use. And so before we can compare the trees, we must select a measurable attribute with which to compare them. So volume and height, or the circumference of the tree, or the area of the land they cover. So when we compare sizes of objects, as you just saw, we must specify a measurable attribute. Can't just say what's greater. So a common activity for young children is to sort a collection of objects in different ways, maybe by color, by shape, and that way they become aware that one object has different attributes and that objects can be compared in different ways. So now the order of measurement. So all measurement involves comparison, and children learn to compare before they learn to measure. For example, children describe measurements numerically. This desk is 3 feet wide, or this bottle holds 2 liters of juice. Then they learn to compare. This block tower is taller than that one, or this bottle holds less than that. So order, or the concepts of greater than, less than, or equal to, underlie the concept of measurement. And then another concept that underlies measurement is additivity. So when we say that a rock weighs 2 pounds, we mean that it weighs the same as 2 1-pound objects together. When we say that a string is 3 meters long, we mean that it is as long as 3 1-meter sticks. Length, area, volume, weight, and time are familiar measures that are additive in the sense that the measure of a combined quantity is equal to the sum of the measures of the individual components. Some measures, such as temperature, are not additive in that sense. When substances of different temperatures are combined, the temperature of the combined substance is not necessarily equal to the sum of the parts. And so this idea that it's a 1 pound or a 1 meter, those 1 we call units. So what does it mean to measure a quantity, and what does it mean when we describe the size, such as 10 feet or 4 liters? So we've discussed that we need to specify the attribute, right? Feet, liters, volume, height. But when measurement involves comparison, it's not just any kind of comparison. It's a comparison with a fixed reference amount of quantity. And that reference is called a unit. So for example, a mile is a unit of length, an acre is a unit of area, a gallon is a unit of capacity or volume, and a kilowatt hour is a unit of energy. When we say, oh, it's 4 feet long, we all agree what a foot is. That's a fixed reference amount. We're comparing how many 1 foot measures or how many 1 mile measures. When we interpret the meaning of measurement, so to measure a quantity means to compare that quantity with its unit. And we don't normally think about it like that. We just say, oh, that's a 5-mile run. But what we're really saying is it's 5 1 miles. So we must determine how many specific units make up the given quantity without any gaps or overlaps. For example, the length of a rug in meters is the number of 1 meter sticks we would have to place end to end. The area is the number of 1 foot by 1 foot squares we would need to cover the rug completely without gaps or overlaps. The weight of a piece of bread in grams is the number of 1 gram weights we would have to put on one side of a pan balance to balance the piece of bread on the other side. And the volume of a compost pile in cubic yards is the number of 1 yard by 1 yard by 1 yard cubes we would need to fill the compost pile. So once we choose a unit, measurements can be described with numbers. What amounts can be used as units? Any fixed amount of measurable quantity can be a unit. But as we move forward, you'll see, and as you already know in your life, we have some standard units. So how do we actually measure quantities? So the most direct way to measure quantity is to count how many specific units are in the quantity. For example, to measure a volume of rice in a bag, we could scoop the rice out cup by cup and count how many cups of rice are scooped. So we've got a You Explore here. Pause. This is a great one. Press play when you're ready to move on. Take your time. To measure lengths, young children can place 1-inch long segments end to end and count the number of segments used. So if we're looking at this caterpillar, we're talking about 1-inch segments. Let me get a different color. 1-inch segments without any gaps or overlaps that measure this length here. So to understand the process and result of measurement, children need to understand and use the concepts. And initially, they may not grasp some of the key ideas. So here's some confusions that you might see. So they may not understand the role of a unit and may use objects of different sizes. So this is a longer paper clip than this one. And so again, this is a misunderstanding of unit, right? We're not saying in a 5 mile, we're going to use, if we say 5 miles, that's not a foot, and 4 miles, that's 5 miles. So we need a consistent unit. They may leave gaps or overlaps. So they may not understand that we're measuring from end to end without gaps and overlaps. And they may not recognize length as an attribute to be measured. And they might not place it end to end. They might instead be trying to find the volume or the area in this case. So a measuring device for length is a ruler. And there's a lot of difficulty with rulers traditionally. A ruler whose unit is an inch displays the number of inch-long lengths. In order to use the ruler to measure how long an object is in lengths, we read off the number of inches on the ruler rather than repeatedly laying down an inch-long object. Can you imagine doing that? That's why we love rulers, rather than laying down inch-long pieces. We could use scales, speedometers, all sorts of different ways, rather than just making a direct count. So go ahead and do this explore. And then press play when you're ready to move on. And here's just some research and literature I encourage you to read from your textbook. So now let's make sense of a ruler. So let's start by first looking at the inches side of a ruler. And again, we want to start it right from the edge of the beginning. And in this case, the beginning is right here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 pieces. This isn't in terms of 10. So this piece right here represents half for the 4th notch out of 8. And this is half of that half, or 1/4. And this is half of that half, that's 3/4. So when we read these rulers, we have to be really careful. When we read this here, we would not say, 2.1, even though it's 1 notch. The problem is that it is, that is the first notch out of 1, 2, 3, 4, 5, 6, 7, 8 notches. That is 1/8. That is 2/8, which can be simplified to 1/4, right? 3/8, and so forth. So we would say that this notch here is 2 1/8 inches. And you can start to see how we're combining fractions, and this is where rulers get really tricky. The great thing is about centimeters is there are 10 little notches in there, and it's really hard for you to see. But in this case, this first notch here would be 2.1 because it is 1/10. So centimeters are great for making sense of measurements in the beginning because they're a little bit easier to read. And we're going to pause here, and when we come back, we'll move into the systems of measurement.